In this video, I'm going to solve this question. Show that for any three events A, B and C with probability of C greater than 0, probability of A union B given C can be written as this. Okay, so this is what we have to prove, right? So I'm going to start with the left hand side of this expression, that is probability of A union B given C, and I'm going to expand this expression using the formula that we have for conditional probability. So the conditional probability formula is this, right? Probability of X given Y can be written as this. So now I'm going to start with the left hand side. So the left hand side is probability of A union B given C. If I use this formula, then I can write it in this manner. So basically see what's happening in this conditional probability formula. This is event number 1. This is event number 2. Okay, so the right hand side is the probability of the intersection of these two events. And then in the denominator, we have the probability of the second event. Okay, similarly, think of this as event number 1 and think of this as event number 2. So on the right hand side, we will have the intersection of these two events. So event number 1 intersection event number 2 divided by the probability of the event number 2. Okay, so I'm using this formula over here. Now let's simplify this further. So over here in the numerator, we have probability of A union B, which is there in a bracket, and then intersection C. Now we can distribute the intersection over union in the numerator. What do we mean by this? Well, this expression that you see over here in the numerator, this can be written as this. So we can write this as probability of A intersection C union B intersection C. Okay, so this can be written as this. This is called distributing intersection over union. Okay, so from here we go over here. Now in the numerator, you can think of this as event number 1 and you can think of this as event number 2. And in the numerator, we have union of two events. Okay, now to keep things simple, I'm going to introduce some notations over here. So instead of this A intersection C, for the time being, I'm writing X as it would become easier to visualize. And instead of writing B intersection C, I'm writing Y. Okay, so these are the notations that I'm introducing. That means as per my notations, we will have probability of X union Y, okay, divided by probability of C. Okay, now how can we write probability of X union Y? This is going to be probability of X plus probability of Y minus probability of X intersection Y, and this is divided by probability of C. Okay, now over here in the next step, okay, so if you see this step over here, let me clear a bit over here. So after this step, you take a look at this step that I have written over here. So in this particular step, I have actually put the values of X and Y. So the first expression that we have in the numerator is probability of X. So X is actually A intersection C. So it becomes probability of A intersection C plus probability of Y. So it becomes probability of B intersection C minus probability of X intersection Y. So this portion is X and then you have intersection and then this portion is Y. Okay, now take a look at the third term that we have in the numerator. It is A intersection C intersection B intersection C. Well, this can just be written as A intersection B intersection C. Okay, so now what do we get in the numerator? So in the numerator, we have three terms over here. So let me show it to you. So we got this, and then this can be written as this. Okay, so that means our numerator becomes this. Okay, and in the denominator we have probability of C. So now we can write it separately like this term, this term, this term. Okay, now what is this? This is probability of A given C. Okay, you can use the definition of conditional probability, and we know that probability of A given C is defined like this. So this is probability of A given C. Similarly, what is this? This is probability of B given C. So we have probability of A given C plus probability of B given C minus, now what is this last term that we have? Think of this as event number 1, okay, and think of this as event number 2. So this is intersection of event 1 and event 2 divided by the probability of event 2. Okay, you can also write this in a conditional probability manner, right? This. So this is minus probability event number 1 given that event number 2 has already happened. It says that in this case, the event number 1 is A intersection B. This is your event number 1 given that C has already happened. Okay, so this is how you can write the right hand side, and that means on the right hand side we get probability of A given C plus probability of B given C minus probability of A intersection B given C, and that's the thing they asked us to prove in the question. So we started with the left hand side, that is this, and now we got the right hand side, that is this. Okay, so that's it for this video.